Hello everyone. Today we will be talking about this quite large, full-featured Sony DVD player. This will be quite a journey, and I think this would be too long for one video, so I'm going to split it up into multiple parts, where we explore the different various modules of this DVD player, and today we are going to start off with the power supply. So, let's bring this back into shot. I have already removed all of the screws, and I can remove the cover. Boom. As you can see, there are multiple sections to it. This is the power supply, which we are going to explore today. This is the disk transport, which interacts with the disk. It reads it, it spins it up, it does all the stuff that needs to be done with it. And this is the control circuitry that controls the way that the disk is read. It processes those signals, turns it into audio output, and there's also another section over here that's kind of hard to see because it's mounted on top of the front panel. There are two boards back there for the I/O, one that handles all the buttons for the input, and the other which is a vacuum fluorescent display and provides a basic user interface for interacting with the DVD player without needing to hook it up to a monitor because you already have some stuff displayed on the screen. So, let's go ahead and remove the power supply because the rest of this stuff will be talked about in future episodes. It is held on by a couple of screws, which I'm going to remove right now. Its screws are removed and it has two connectors, the mains input connector, which I will remove with a screwdriver. Probably not the best way to do it, but it's quite violent and it does work. And then there is the output connector, which has a ridiculous amount of wires and makes me wonder if some of the power supply stuff is actually being handled by this giant thing of control circuitry. But the main thing that we're interested in today is the power electronics part of the power supply. So let's go ahead and pop off this connector, if I can get it in there, because this connector is quite annoying. There we go. Now we can lift the board out. The board is also quite annoying to remove. It's kind of recessed, and it's held in place by all of the stuff that's on top of it, but it can still be removed with relative ease. So let's go ahead and discuss some of the stuff that's on it. So of course we have the mains input connector and a fuse to protect against random short circuits in the rest of the stuff. There is a filter capacitor for interference suppression, which basically removes all of the high frequency voltage that the switching power supply radiates back into the mains. And this capacitor works along with this inductor, which has two windings for both the live and the neutral. And then after this interference suppression and fuse, it goes into this full bridge rectifier, which for some reason is in a DIP8 dual inline package, but only 4 of the pins are in place. I have never seen anything quite like this before, in real life or on YouTube. And then there is the main smoothing capacitor. It is 82 microfarad, 200 volt. If you can see. And of course this, the full bridge rectifier turns the AC into a bumpy DC, and this electrolytic capacitor smooths out the DC so that it can be used by semiconductors and everything else that would be needed. And then there is this mysterious component. I'm not sure what it is. I assume that it is the switching MOSFET and control circuitry in a single package. And it's a plastic TO220 package. I think there's a specific name for this, but I just call it a plastic TO220 package. But instead of having 3 pins like normal, this one has 5 pins. And then there are some resistors and capacitors that are probably used for snubber and this little blue capacitor right here is probably the snubber capacitor, and one of these diodes is probably a snubber diode. It can't be one of these tiny glass diodes, can it? Or maybe the snubber diode is integrated into this. And then there is the class Y interference suppression capacitor, which prevents some of the interference radiating from this to get into the output. And this capacitor is critical for safety because it connects the primary and secondary side, so this capacitor has to have a high voltage rating in case there is a high voltage static discharge that could damage the capacitor and cause a large amount of current to leak from the primary side, which is connected to mains, which is basically death, and the secondary side, which is often connected to you. This isn't a phone charger or a computer power supply. All of the stuff is located... because this is a DVD player, all the stuff is located safe inside a plastic box. But if this was a computer power supply or phone charger where all of the secondary side stuff is connected to your phone, then that could be a safety issue if this capacitor fails short circuit. Then there is the optocoupler, which basically allows the primary side to sense what's going on the secondary side and adjust the way that it switches the transformer to compensate for anything that's going on with the secondary side. Speaking of the transformer, it has a bunch of pins. One of these is probably an auxiliary winding. In fact, let's take a look. This pin that seemingly just goes to the positive of the bridge rectifier is actually, it probably is used as an interference shield, which helps get rid of the interference from the primary side going over to the secondary side. Which helps along this capacitor, so the secondary side will have barely any interference. And then there is the primary winding, which is the winding that's actually being switched by the chip, and the auxiliary winding, which which provides this chip power. It's basically a secondary, but on the primary side. And then the secondary side, there are probably multiple secondary windings that are all wired in parallel for extra current capability. And all of these little solder splashes over here that don't actually have any pin going through them are to increase the current carrying capability of these traces. And then on the secondary side, this diode right here is probably used for the high-frequency rectification. It's probably a Schottky diode. And then there are some capacitors, relatively big capacitors, to help with the smoothing. And then some inductors and crap, which also help with the smoothing. And then there are these weird packages. They look like the typical TO92 packages that you would find small BJT transistors in, but these are double the height. They actually look kind of like capacitors, but as you can see, they have 3 pins, and on the board it actually has markings B and E, which I'd assume stand for base and emitter, which are of course the typical the words used for BJT control gates. And then there is, of course, some resistors and capacitors, and whatever these green things are, they might be resistors, they might be inductors, I don't know. Then there are some extra capacitors and resistors and junk, and then, of course, the output connector, and the power switch, which probably goes immediately to the output connector, and in fact, some of the connections do go straight to the output connector, it seems, and it just tells the main control circuitry to wake up and start and get ready to accept a disk. Anyway, that's about it for the power supply, and next video we are going to talk about the CD, or I guess DVD transport.